Hello, I am one. Welcome back to Math of Linear Equations. Here we are in part 2. If you remember, I had decided that I wanted to teach final lessons of this year, Math of Linear Equations, because it's an important part that needs to be learned as you move on from IM1. So here's the overview that I covered last week. Just wanted to make sure that you remember some of these things. So we talked about the slope of a line, and we talked about the formula for the slope of a line and how to find those things. We talked about the equation of a line in slope-intercept form. We reinforced the idea of equation of a line in standard form. We graphed a line using slope and the y-intercept. We graphed a line using a point and a slope, and we graphed a line using a table, and we graphed a line using 2 points. That was the first part. Beyond that, now we're going to get into really working with the idea of writing equations of lines. In the homework, there was a couple of places where we did have you already do that, but in part 2 here, we're going to be focusing on writing the equation of a line when you're given 2 points, writing the equation of a line when you're given a slope and a y-intercept, write the equation of a line that is parallel to a given line and passing through the given point, writing the equation of a line perpendicular to a given line and passing through a given point. You need to also be able to find the point where 2 lines cross, be able to determine if 2 lines show no solution, and be able to determine if 2 lines are the same line. On those last two, I'm just going to go over them right here and right now. That to be able to determine if 2 lines show no solution, that's always happening when you have 2 parallel lines that have different y-intercepts. And so all you have to do is look for the slope of both lines. If they're the same, then they do not cross. But that's only in the case where they have different y-intercepts. If they have the same y-intercept, then that last one, be able to determine the 2 lines if they are the same line. Now we're talking about the same line. And sometimes the way that things are as far as just multiples of the coefficients on the variables, you could have a representation that looks different just because it might be a multiple of the coefficients of another line. So that's the case in which we have the same line. So moving right along, let's just go ahead and do some things with examples here. Here is writing the equation of a line in standard form. And notice what this is asking. It's asking for it in standard form that passes through the points -5, -3, and 4, 2. And then also graph this line. You have learned how to do this using the slope-intercept. And so we're going to use the slope-intercept form in order to solve this problem. And then after we're done with it all, we'll translate it to standard form. So let's just do some things that you already know. And here's just more practice. So the very first thing that we're going to have to do is find the slope. So the slope of the line, we're going to use the formula again. Slope is equal to, and I'll just go ahead and write the formula, y2 minus y1 over x2 minus x1. And let's label the points. This is x1, y1, this is x2, and y2. So we're going to find the slope. Slope is equal to 2 minus -3 divided by 4 minus -5. Negative negatives become positives. 2 plus 3 equals 5. 4 plus 5 equals 9. And there's our slope. The slope is going to be 5/9. So then we write the equation of the line. What is the equation of the line? Y equals mx plus b. And we're going to write it again. Say y equals 5/9 x plus b. And now we have to find what b is. And so you know by now that what we need to do is just simply put in the coordinates of one of the points, and we'll find b. And it doesn't matter which one you use because you're going to get the same truth no matter which of those points you're going to use. So let's use the second one. y2 is 2, so we're just going to replace the y with 2, when x2 is 4. So we're going to say 5/9 times 4 plus b. And that's going to help us solve the b, which is the y-intercept. So let's go ahead and do this. This is 2 is equal to, this is 4 over 1. We multiply across, so 5 times 4 is 20. 9 times 1 is 9 plus b. So we have to subtract now 20/9 in order to get b alone. And so now we look like this, and I'm going to write it to the left over here. 2 minus 20 over 9 is equal to, and this is 0 over here, so b is all by itself, is equal to b. Well, we can write that 2 as a 2 over 1, and that kind of prompts us to say, oh, I need the same denominator, and so I'm just going to go times 9 and times 9. And so this really looks this way. 18 minus 20 divided by 9 is equal to b. 18 minus 20, that's a -2 over 9, and that's equal to b. So now we can finally write our equation of our line, and that's going to take rewriting this guy right here, so I'm just going to put that there. Y equals 5/9 x minus 2 over 9. And that's it in slope-intercept form. But we're not done because we've been asked to write the equation of the line in standard form. So let's write this in standard form now. The first thing I'm going to do is I'm going to take all my fractional numbers and turn them into integers because standard form requires that all the coefficients and numbers be in integer form. So we're going to do that. So in this case right here, remember I said you can flatten out a fraction by multiplying the fraction by whatever number is in the denominator if it isn't 1. So we're going to do that. We're going to multiply everything by 9. So that's going to be 9 times y is equal to 9 times 5 over 9 x minus 9 times 2 over 9. Now look at what happens here. 9y just simply is 9y. 9 cancels 9 here, and 9 cancels 9 here. And we end up with now 9y is equal to 5x minus 2. And we're almost there. All that we have to do is get the variables all on one side. I'm just going to put this up here. And we're going to take 9y is equal to 5x minus 2. So I'm going to subtract 5x from both sides. And I get now negative 5x plus 9y. 5x minus 5x is 0 equals negative 2. I want you to see that this is a correct answer for this question because we can say that a is equal to negative 5, b is equal to 9, and c is equal to negative 2. And that's how we identify that this is in standard form. Those numbers are all integers. Now I wanted to show you something a little bit different. What if we, instead of subtracting 5x from both sides, we took that same equation, 9y is equal to 5x minus 2, and I decided instead to subtract 9y from both sides. And then I'd end up with this. 0 is equal to 5x minus 9y minus 2. Now I'm going to add 2 to both sides, and I end up with 2 is equal to 5x minus 9y. Well, there's this thing called the symmetric property of equality, which means I can take the left side and move it to the right side if I take the right side and move it to the left side. So we'll do that. 5x minus 9y is equal to 2. And notice that I have now an expression that is really an equivalent expression to the expression that I have up here. Only take a look at the difference. Notice where I have negative 5x, I have positive 5x. Where I have positive 9y, I have negative 9y. And where I have negative 2, I have positive 2. So let me just take one last sweep at this thing and just say, well, what happens when I multiply all the terms by negative 1 of this guy right here? So I'm just going to go times negative 1 times negative 1. And that takes distributing on the left. Negative negative is positive, 5x. Negative times positive is negative, 9y. And negative times negative is positive, 2. And look at that. So all it takes, and this is just showing you and proving to you that you can multiply both sides of an equation by the same number and still get equality. All right, moving right along. Example 2 says write the equation of a line in slope-intercept form that is parallel to the line 3x minus y is equal to 8. Now that's in standard form and we need to know what the slope is, and also passes through the point negative 2, 3. We're going to have to turn this equation of a line right here into something that's in slope-intercept form in order so that we can readily see the slope. So we're going to copy it down here, and I'm going to subtract 3x and get negative y is equal to negative 3x plus 8. That's not in slope-intercept form yet because I have a negative y out there, so I'm going to multiply everything by negative 1. And that turns that into a positive y is equal to negative 1 times negative 3 is positive 3x, and negative 1 times positive 8 is negative 8. And there we are. And we're in slope-intercept form. And what is the slope? Well, the slope is, you can see it, it's that number that's in front of x. It's not 3x, it's just 3, which means it's 3 over 1 for the purposes of rise over run. So there's the slope. Now, we're going to be talking about parallel. And you'll notice what I wrote down here. I said, in parallel lines, slopes are the same. In parallel lines, slopes are the same. So what is going to be the slope of the line that is parallel to this line when we write it? Well, it's going to be the same. So this is the slope, and we're talking parallel, so we don't change the slope. So we start off by, we need to write the equation of the line. So we're going to say y equals mx plus b. What's the slope of our new line, the solution line that we're going to be writing? We know it's going to be 3, so y equals 3x plus b. We don't know what b is yet, but we're given information here. We're given that it passes through that point, and any point that's on a line makes that line true. So we're going to say then, when y is equal to 3 from that point, x is equal to -2. So I get the slope 3 times -2 plus b. Now we have enough information to solve for b here because we have numbers all around. 3 is equal to 3 times -2, which is -6, plus b. I'm going to add a 6 to get rid of the 6 on the right-hand side and move it to the left. 3 plus 6 is 9. b is equal to 9. So if b is equal to 9, then I can finish this problem off now by just rewriting this. Y equals 3x plus 9. And that is the answer to this question. And this one's asking for it in slope-intercept form. That's the reason why we're done at this point. We've written it in slope-intercept form. Moving it on to example 3, write the equation of a line in slope-intercept form that is perpendicular to the line 2x plus 5y is equal to 7 and passes through the point for -1. And notice I wrote you a little note at the bottom of this note too. It says, in perpendicular lines, slopes are opposite reciprocal. Opposite meaning if it's a positive number, opposite of that is a negative number. And reciprocal means if it's a fraction, and any integer number or whole number is a fraction because you can put those things over 1. And reciprocal means flip it upside down. Make the denominator the numerator and turn the numerator into the denominator. So we're going to do that. We need to first determine what is the slope of this line. So it's written in standard form, and so we're going to write that. We're just going to take it again, and we're going to do those things that we do in algebra where we can add things to both sides or subtract things from both sides, and then we're going to multiply all terms in order to gain equivalent expressions. So we'll start off by subtracting 2x, and that leaves 5y by itself on the left. We have minus 2x plus 7. And now I don't have slope-intercept form yet. We still need that, but it's going to take dividing all terms by 5. And so we have y now by itself, because 5 cancels here. Y equals -2 fifths x plus 7 fifths. And there we are in slope-intercept form. What is the slope? The slope is -2 fifths. It's not -2 fifths x. It's simply the number in front of the x is the slope. So the slope is -2 fifths. Now, I've told you this before. I like to use this little symbol for perpendicular slope. So if the slope is -2 fifths, then the perpendicular slope, it looks like an upside down capital T right there. That's the symbol for perpendicular. The perpendicular slope is going to be the opposite reciprocal. So if it's going to be the opposite reciprocal, then let's go opposite. Well, this is a negative number, so it's going to be a positive number. And we're going to take that fraction and turn it upside down. 5/2. Sometimes I've been having a test question where you guys are putting the perpendicular slope, and you'll remember that it's one of those two, but you don't remember that it's both of those two. We have to go the opposite, and we need the reciprocal. So turning it upside down is simply not enough. You need to make it the opposite sign of what it started with. Turning it negative is simply not enough. You also need to flip it upside down. So the opposite reciprocal slope of our new line is going to be positive 5/2. All right, what's the equation of a line? Y equals mx plus b. And we know the slope of the line that we're trying to write now. It's 5/2. And now we have to work at solving b. But that's okay because we have the point. We know that this point right here is saying when y is equal to -1, x is going to equal 4. So we're just going to replace the y and x with those numbers. Y is equal to -1 when x is equal to 4 plus b. And we could do it this way. 5 times 4 is 20, and 20/2 is 10. We'll say plus b and plus b. And we still have -1 and -1 because we haven't done anything with the -1. But now we're going to subtract 10 to get b by itself. 10 minus 10 is 0. b is equal to 1 plus 10 is 11, but those are negative numbers, so it's -11. b is equal to -11. And we're just about there. We could take this guy right here and rewrite it down here and replace b with -11. Y equals 5/2 x minus 11. And we're done. There is the equation of the line that is perpendicular to the given line and passing through that point. One of the final things that we had done this year was to talk about systems of equations and the idea that there's a couple of methods that we can use. One of the methods was called substitution. The other method was called elimination. And so I wanted to remind you that this is how this works. Now, before we do that, though, let me remind you what this discussion is about. We're giving you two equations of lines. And this is the spaghetti on the kitchen floor scenario that I told you a while ago. If you looked at any two lines on a coordinate plane, those two lines can only relate to each other in three different ways. One way is that they are going to cross, and if they cross, they will cross at a single point. And the systems of equations problems like this will help you solve what that single point is, and we can actually come up with the coordinates of the point at which these two lines cross. The second situation that those two lines can coexist is that they are parallel and having different y-intercepts. And if they're parallel and having different y-intercepts, then they're just two lines that sit on the coordinate plane and never cross because they're parallel. The third situation is that the two lines are actually the same line. And you remember I told that, talking about cheap spaghetti, where sometimes you pull out of a package a piece of spaghetti that's actually two pieces that never separated from each other. And so therefore, every point of one line is equal to every point on the other line, and so they are the same line. Those are the three different ways. They cross at a single point, they don't cross at all, and if you try to solve where they cross, you get no solution, by the way. And in the third case, you get every single point that you try is every single point of the other line. And so you have the solution part of it comes out to be, I have an infinite number of solutions. Here we're really focusing on just, let's find that single solution. So it's the first case right here. And in this case right here, we're talking about solve the systems of two equations using substitution. Notice what we have here. We have two equations. This one right here is written in slope-intercept form. And this one right here is actually written in standard form. But when we're using substitution, what I want you to understand is that substitution simply means that I can substitute for one side of equals the expression that's on the other side in another equation. And what that's going to do is show that we can actually find that line in which these two cross. So this is what I'm trying to say. Notice that first equation says y equals 2x minus 3. I'm going to put parentheses around this just to kind of emphasize that equals means wherever you see y, you could write 2x minus 3. So now we're going to go ahead and talk about the other line. And we're going to say, I see x minus y equals 1. Well, there's y. And y equals 2x minus 3. So watch what I can do. In the second equation, I can write x minus, and I'm just going to put a set of parentheses in here, and I'm going to put parentheses in there, 2x minus 3. And then I'm going to finish writing that second equation. Well, look at what I did by doing that. Now I only have an expression that has x's, and I know how to use my algebra to solve expressions. And so we're going to start off by, let's get rid of those parentheses by using distributive property. That says negative 1 times 2x minus 3. So negative 1 times 2x is negative 2x, and negative 1 times negative 3 is positive 3. And there's that x from the front of the other part there. Okay. Now I have x minus negative 2x. Well, that's just negative x. Plus 3 is equal to 1. And I can subtract 3, and I get negative x is equal to negative 2 when I combine the 1 and the negative 3, and I can divide everything now by negative 1. And I get x is equal to 2, because negative over negative is positive. So x is equal to 2. And I've got the second equation is the easiest to use, so I'm just going to use it. I'm going to replace x with 2, and by the way, that's a substitution, because I know that x is equal to 2. Minus y is equal to 1. And there's enough information to solve for y. We're going to subtract 2 from both sides. And I got negative y is equal to negative 1. And I'm going to divide both sides by negative 1. And I got positive y now is equal to, negative over negative is positive 1. So that means my solution then is 2, comma 1. Now, if that's true, 2, comma 1 will be a truthful solution for the other line. So let's see if that works, okay? I can say y equals 2x minus 3. Will that be a truthful statement if I stick in the coordinates from 2, comma 1? Well, y is equal to 1 when 2 times 2 minus 3. 2 times 2, 4. Minus 3, 1. And 1 equals 1, And that's a true statement. So we've checked it, we've done it, we've solved the system of equations. It's a single point. That single point is 2 comma 1. Example 5. This is another systems of equations, so it's still referring to the two lines, and that you can only think about those two lines in 3 different ways. But the way that we're going to recognize these is that this is a system of 2 equations that can be solved and come up with a single point by using elimination. This one's a little bit tougher. This is the tougher version of it, and I want to show you that we're going to be using pieces of algebra in order to make this work. Now, elimination is one of these things where it's like, if you add straight up and down, you'd really like for something, one of the variables to go away. Well, if we just look at this system, nothing happens because 6x plus 3x, that's 9x, and 2y plus 3y is 5y. Nothing's really going to happen with this one unless we change something. But notice what we can do. There are legal things that we can do to make this happen. Since 6x is 2 times 3x, why don't we multiply by 2? And as a matter of fact, multiply by negative 2 so that when we add them together, the 6x minus 6x just becomes 0. So this is what I mean. I'm going to take 3x plus 3y, and and that's equal to negative 13. And I'm going to multiply all of this by negative 2. And when I do that, I get negative 6x when I'm distributing this, and I get negative 6y, and I get negative times negative is positive 26. So that gives me negative 6x minus 6y is equal to 26. Hey, let's go ahead and just copy this down to here. We're going to do this thing called elimination. So all I'm doing is copying that first equation, and I'm adding it to a multiple of the second equation. I multiplied it by negative 2. Negative 6x plus 6x, 0. Negative 6y plus 2y, negative 4y. 26 plus 10, 36. Divide by negative 4, divide by negative 4. These go away. Y equals 36 divided by 4 is 9, but that's positive over negative, so it's negative 9. How convenient. So now I can just take that y equals negative 9 and substitute it into one of the 2 equations, and I'll have the x coordinate. So let's take that second one because it's easier to multiply by 3, I guess. So we're going to say 3x plus 3 times negative 9, because we already solved for it down there. Y is equal to negative 9. And that's going to equal negative 13. Okay, 3 times negative 9, negative 27. So we're going to rewrite this again. And I'm going to add 27 to both sides. So that's essentially 27 minus 13, isn't it? So 7 minus 3 is 4, and 2 minus 1 is 1. I get 14. And I got 3x is equal to 14. And if I divide both sides by 3, I have solved for x. So 3 cancels 3. X is equal to 14 over 3. So my answer is 14 over 3, comma, negative 9. Now I'm going to solve this problem in a different fashion. And let's do it again. Let's see if we get the same answer. So this time, instead of making 6x match with 3x by multiplying by negative 2 on the 3x, I'm looking at that 2y and the 3y. And I'm saying this, well, 2 and 3 have a greatest common factor of 6. Why don't we multiply by whatever it takes to turn those into 6's and eliminate the y's and see if we get the same answer, okay? So we're going to do this. We're going to do 3 times 6x plus 2y. And if I do that, I got to do 3 times 10. And I'm going to multiply the other one by negative 2. And that way I get negatives canceling things out. And I get negative 2 times 3x plus 3y is equal to negative 2 times negative 13. So that's going to use some distributing. 3 times 6x is 18x, plus 3 times 2y is 6y, and that's equal to 3 times 10 is 30. And down below, negative 2 times 3x is negative 6x. Negative 2 times 3y is negative 6y. And that's equal to negative 2 times negative 13. Negative times negative is positive, and 2 times 13 is 26. Now I'm just going to add straight up and down. 18x plus negative 6x, that's 12x. And I got 6y minus 6y, that's 0. And that's equal to, if I add together 30 plus 26, I get 56. Now if I divide by 12 and divide by 12, You go, ha, you didn't get it. It's 56 over 12. Well, I'm going to go, well, I can divide 56 by 4. And if I do that, I get 14. And if I divide 12 by 4, I get 3. Yes, I did get it. X is equal to 14 over 3. And if I use 14 over 3 and I stick it back into one of the problems, like I'll do 6 times 14 over 3 plus 2y, I get 10. So 6 cancels 3 and becomes 2. 2 times 14 is 28. Plus 2y is equal to 10. So I'm going to subtract 28, and I get 2y by itself, because 28 minus 28 is 0, is equal to negative 18. And if I divide by 2, I get y equals negative 9, which is what we knew because that's the point that we had gotten before. And that's example 5. Solving a system of equations using elimination. So I wanted to remind you, and you can grab a copy of this set of notes to have this, but these are rules of algebra that I've been using, and they are always valid. You can move terms in equations by adding to both sides any expression, or you could subtract from both sides any expression, and that will not upset equals in an equation if you do it properly. You can multiply or divide in equations. You can multiply or divide all the terms of an equation by the same number and maintain equality. And you've seen how we can flatten out fractions, or we can shrink a coefficient to 1 by dividing by that coefficient, and things like that, and it maintains an equality. You can add or subtract the like terms of equations to create a new equation. So you just can combine like terms. And then understand how to take advantage of things like adding 0 and multiplying by 1. Let's talk about that for a second. If we add 0, 0 doesn't have to look like 0, because 0 could simply be 4 minus 4. And that's what we're doing sometimes when we're just trying to move something around. We're turning it into 0 on one side of equals, and we're turning it into whatever it turns out to be on the other side of equals. Or you can multiply by 1. Well, multiplying by 1, it doesn't look like you're multiplying by 1, but when you're multiplying fractions or trying to get something to turn into a 1, you can multiply top and bottom of a fraction by the same number. And sometimes it doesn't look like 1, because 3 over 3 doesn't look exactly like 1, but it is, because 3 divided by 3 is same as 1. So understand how to add 0 and multiply by 1. These are simple rules from algebra that you need to be competent with, and in order to be able to do these kinds of problems very well. So here's your homework. I'm providing you a combined worksheet for homework 9B. It's 2 parts because I couldn't get all the problems from a single program. I had to take from another program. So I've given you answers so that you can check your answers, but you should do the problems by not looking at the answer, and finish the problem and just go, did I get the answer right? Check it with the answers that I provided, and if you did, congratulations, you did the problem right. If you can print a copy of it, then do it and do your work on that and turn it in. Or if you need to do your homework on a separate piece of paper, as you've been doing, you can do that, and you can take a picture of that. And when you do graphing and stuff like that, just make sure that you're being very careful about making your graph accurate. Turn that in, and that'll be it for this homework set. All right? Thanks a lot. We'll talk to you later.